I wonder who this is.
I got a box for you.
Hi.
I got a box for you.
Thanks?
Got a box for you.
Yeah, okay.
Thank you.
No question said. Well, I guess let's see what's in this tormented box that's been ripped and wrinkled and oh god. Okay. So there's a mail in a box that has 500 pieces of wrapping. I'm not gonna ask. Well, let's see what this says. The Density Song. Hello, my name is Density, and also my brother Buoyancy. I would like you to sing a song all about me outside. And it has to be done outside, otherwise it's not gonna look cool. Okay, thanks. I will be hearing it off your YouTube channel, and bye. Oh, it also says somewhere here. Please sing the song without no further notice. Okay. I guess I'm singing a Density song. Well, 3, 2, 1. Now this is a song all about how density determines the matter inside a object. I'm about to say to you is nothing more than the best thing that you've ever heard. Now, the first thing that I'm gonna say is basically about density. To find a door, I gotta go into just more detail. So the first thing that I gotta say is you need to know the formula to find density. Now, the formula that you gotta know is mass over volume equals density without no doubt. So what is volume? Well, volume is a quantity of a three-dimensional space enclosed by a closed surface. No way! For example, the space that a substance, solid, liquid, or a gas, or plasma, or a shape occupies or contains. The volume is often quantified numerically using the cubic meter. The volume of a container is generally understood to be the capacity of the container, the amount of fluid, gas, liquid that the container could hold, rather than the amount of space that the container itself displays. What? Also, to find volume of an object, go ahead and do length times width times height times width, and you'll get the volume of that object. What? Now that we've gone into just volume, let's go right into just mass. Mass, it ain't no joke. Now let's go ahead and see what it's got. So what is mass? Mass is a measure of the amount of matter in an object, and usually measured in grams or kilograms. Also, an object's mass is consistent in all circumstances. From Mars to Earth, it doesn't change. That's how it works. Mind blown! Now that you know the definition of both mass and volume, let's go ahead and use it to see how we find density. So what you gotta do is first grab a ruler. What, a ruler? Yes, a ruler. Then go ahead and find the length, the height, the width, and then multiply them together and you'll get the volume. Now the next thing that you gotta do is get your poop in balance. Once you get the true imbalance, go ahead and just find the mass. Now how you do that? Let's say you want to find the mass of a wrapper, so you go ahead and get a triple beam balance. Once you've got that, go ahead and move the 1 gram beam one by one till you get to the balance mark. Once you've got that, see what the mass is, and that's the mass of the object. So now that you know the mass, you got the volume, go ahead and use the formula to find density. That, go ahead and do mass divided by volume. So now congrats, because you just found the density of an object. But what is density? You're wondering? Well, let's go ahead and see what is the density. So density is a measurement that compares the amount of matter an object has to its volume. An object with as much matter in a certain volume is a high density. Without no doubt, that's what it's got to say, so roll its ways. Density is a measure of how compact the mass in a substance or an object is. The density of an object or substance can be calculated from this equation. Density in kilograms per meter cube is equal to mass in kilograms divided by the volume in meters cubed. The density of substance in a relationship between the mass of the substance and how much space it takes up. The mass of atoms, their size, and how they are arranged determine the density of a substance. You know what density is? Let's see how it connects with the buoyancy. Well, once you find the density of an object A, you go ahead and see if it is more or less than 1 gram per cubic centimeter. Well, if it's more than 1 gram per cubic centimeter, the object is gonna go ahead and go into ink. But if it's less than 1 gram per cubic centimeter, it's gonna go ahead and just float. Now, why is that? Well, buoyancy, or the upward thrust, is the upward force exerted by a fluid that exposes the weight of an earnest object. In a common fluid, pressure increases with the depth as a result of the weight of the overlying fluid. Thus, if the pressure of the bottom of a column of a fluid is greater than the top of the column, the pressure difference results in a net upward force on the object. And the magnitude of a force is proportional to the pressure difference. And as explained by Archimedes, the principle is equivalent to the weight of the fluid. Also, density reduces with increase in volume, whereas buoyancy increases with volume. So they are both inversely proportional to each other. So, when an object whose average density is greater than the fluid in which it is submerged into sinking, if the object is less dense than a liquid, the force will keep the object floating. Mind blown! So now that you both know the density and just the buoyancy and how they work, I'm just gonna go ahead and head out of these.